but without further ado, let's go ahead and get started. So I'm going to, hold on, that's the wrong button. I'm going to share my screen, and we had planned on doing some sort of tech testing, but here we go anyway. So you should be seeing a screen with the slides. Is that correct? All right,
Yes.
great. So for sake of time, let's get started. We have 45 minutes left in our session. So let's go for it. So there's two pieces to this session before I get started with the content. We have a Slido where you can go put your questions in. We have that already pre-set up. There's a link here I'm going to copy into the chat for everyone to use. So put your questions in there. And then we also have a live note-taking document where anyone can log in and take notes on the meeting and help us get the ideas written down. And if you don't feel like speaking up, you can put your notes in there and you will still be heard. All right, so that's the ways to interact here. Let's get started. So this is a session on publication validation in the natural sciences. We're looking for innovative solutions based on the successes in other sciences. So our motivation here is that we want to figure out a potential process for publishing that better supports publication validation in open science, and we want to get feedback from the experts that have agreed to present and the other experts in the room. Looking to collect all the bright ideas and see what we have. The desired characteristics are that we want better metadata for connected artifacts, particularly so that we can better connect them together. And we don't want, for the publications, we don't want to just take the author's word for it, that they get the solution they promise. We want them to do some level of proving to get that. We want a more flexible process for the data software submission process. And we want the doesn't work for me problem fixed. Now, I say that, but realize that we can't fix that problem for all of the thousands of publications in the natural sciences. So how to make that approach reasonable? Looking at approaches that others use, just two examples would be the Center for Open Science has badges where they do some sort of review of the materials and review of the data and so on. The Association for Computing Machinery, their approach is to randomly select publications for more detailed review. And I know just based on other approaches I've heard of that there are other things out there that we want to analyze and see how we can piece this together. So our session format, I have the three thinking questions here. They're also in the notes document, along with basically a straw man to shoot at for some sort of idea of how we can move forward. The thinking questions that I want the audience and anyone attending and presenting to think about would be, how can repositories, journals, reviewers, and authors collaborate more efficiently on the publication process? How can we make it more flexible? And what changes can we reasonably make to simplify how to validate a publication? We're going to start with a few scene-setting talks of about 7 minutes each. I have to be a little strict on the timing because of our timing. We have a short session here. So first, we're going to have Amanda Montoya using pre-registrations in the natural sciences. Feel free if you changed your title to go for it. Then we'll have Matthew Giampuala. I hope I did a reasonable approach of your name on the AGU peer review process, followed by August Munch. I'm sure I screwed that one up. Okay. On the data editor approach to open science, and the one I should know, Alberto Alcamazzi on promoting fairness via metadata enrichment in the NASA Science Explorer. So again, 7 minutes per talk. I'll try to give some sort of indication at 6 minutes to give you that 1 minute warning. All right, so I will stop sharing and hand it off to Amanda.
Okay, let me try to get slides. Oh. Yeah. Are you guys seeing slides? I don't see you anymore, so I need
We see your slides. Go for it.
Okay, cool. Great. Super. My name is Amanda Montoya, and I'm going to be talking today about registered reports, which is a new publication process that has been adopted in the social behavioral sciences. I wanted to share a little bit about where I'm coming from, since part of this session is about coming from other sciences. So I have two kind of parallel streams of training, one in the area of psychology with a focus on methods and experimental design, and quite a bit of training just in pure mathematics and statistics as well. My research experience is primarily in the quantitative social behavioral sciences. So I live in a psychology department. I work with people in business marketing and decision making and education. And I'm going to be talking today about registered reports. I say this as an author of multiples of these, an editor and reviewer, and actually a line of my research is meta-science studying the adoption of registered reports. So just a basic outline of what I'm going to do today. I'm going to talk about the basics of registered reports and then a specific tool called Peer Community in registered reports. Talk about some of the benefits and barriers we're experiencing thus far in the social behavioral sciences, and then what are the future directions for the natural sciences. I wanted to shout out to two of my colleagues here at UCLA, Mackenzie Day and Roger Varney, who both consulted with me on this presentation because I didn't know a lot about the natural sciences. So what problems were we experiencing in the social behavioral sciences? We have a lot of problems with publication bias, which is this underrepresentation of null results in published research. We have problems with what we call harking, hypothesizing after results are known. And so this is presenting what really was exploratory research as confirmatory after the fact. And also people taking advantage of excessive analytic flexibilities in order to find the results that they want. And that's often called p-hacking. So registered reports came in to address a lot of these problems. And the basic idea with a registered report is, in contrast to a traditional manuscript, when you do all of your work, you develop an idea, design a study, collect and analyze data, write a report, and then you send it out for peer review all the way at the end. The difference with registered reports is that after you develop your idea and design a study, you go through a stage 1 peer review process. And this process is actually going to determine whether or not the journal commits to publishing the results of the study, regardless of how they come out. So this is called an in-principle acceptance, where the journal says, hey, just do things the way that you said that you will do them, and we will publish your paper. And then the researcher goes off and does their own research and comes back, and there's a stage 2 peer review, which is assessing kind of the adherence to the original plan. I've never seen a single registered report that had no deviations from their original plan, but part of what this does is it makes it very transparent what those deviations were. So what are the impacts of registered reports? Well, the basic idea is we're trying to address a lot of the concerns that were coming up in social behavioral sciences by introducing peer review and acceptance before results are known. This should reduce publication bias or any decisions that are based on significance of results. And additionally, because hypotheses and analysis plans are established before examining the data, we should be reducing issues like p-hacking and harking. Registered reports have also been paired with a number of other open science practices, and most of their implementation has incorporated these. So a couple talks today have talked about pre-registration, this idea of writing down your plan and putting it in some kind of repository. Registered report is kind of a plus version of pre-registration. Many journals that do registered reports require open data, and there have been some recent studies that show that registered reports have higher rates of open data and code, and also more replication studies. One of the things that's really helpful about registered reports in combination with replication studies is that researchers often find these difficult to publish, because if you do successfully replicate the results of somebody else's paper, a journal might say that's not interesting, we already knew that. But if you fail to replicate, then a journal might say you probably did it wrong. So registered reports are a really good way to make sure that we're publishing replication studies. There's been quite a bit of meta-science looking at the quality of registered reports, and overall, the findings are really good. So in general, registered reports are perceived as more rigorous, higher quality. They are not less innovative or novel, and essentially score better than or equal to traditional publications on all criteria that they were evaluated in. There was another study that also looked at computational reproducibility of registered reports and found them to be more computationally reproducible. So what is going on with these? There's about 350 journals that have adopted registered reports, but very few in the natural sciences. So I pulled a few, which are, there's kind of a couple frontiers journals that do this, and then a number of funding agencies have adopted this at their repositories. One thing I wanted to mention, though, is that a suite of nature journals have already adopted these, so including Nature, just period, but also Nature Climate Change, and I think that they already have the infrastructure to adopt this at any other nature journal that might be of interest to your field. There's also this really great resource called Peer Community in Registered Reports, and the idea behind this is that you don't need a journal to do a registered report. It is a community of researchers that do the review process independent of a journal. And the basic idea is you submit a stage 1 submission to PCIRR instead of to the journal, and it's peer reviewed through their system. They give a recommendation, and then eventually you upload your paper to a preprint server. And then ultimately you resubmit your paper back to them. And in the end, you can send this to a PCIRR-friendly journal. So a PCIRR-friendly journal commits to accepting registered reports without further peer review if it's been recommended by PCIRR. There are a number of friendly journals, but again, very few in the natural sciences. I tried to pull a few. So what are the benefits? Well, it addresses all of the things that we say that it should address, but it also avoids wasted resources. So if in the peer review process you're asked to run new studies or rerun previous experiments or redo data analysis, the idea is that this should shortcut that. It's also really valuable for expensive or risky research because you know that it will produce a publication. It should avoid journal shopping because of this reduction of publication bias based on results, and is also used to encourage replications. So there are still a lot of barriers. We need more journals to adopt. Researchers still don't really understand how the time works in this process. And so far there have been limited integrations with the funding process, which would really be ideal is if a registered report and a grant proposal could be reviewed at the same time. So ultimately, the question is, are registered reports right for natural sciences? I think ultimately they're going to require some tailoring for each individual field, and getting people more familiar with these is going to help identify what the needs are in natural sciences and how registered reports can fit those needs. There's also a really important aspect of exploratory research. It feels like registered reports are not appropriate for these, but it actually is, and a lot of the work that I do is exploratory. If we think of peer review as a means of assessing a quality of a plan, then getting feedback earlier is always better. This is not dissimilar to a dissertation proposal model, and it also allows us to confirm whether research was truly confirmatory if it is pre-registered.
Hey, Amanda, we're over time. Could you
Yes.
maybe jump to your last slide and let us look at it for a moment?
Yeah, so this is my last slide. What are the next steps? I put up here the policy or the theory of change model for the OSF. And I think right now we're in the stages of we need to make this easier for people to do. This could include integrating PubSpace and other frameworks in the natural sciences into the registered reports process. And we also need to make it normative and rewarding. So figuring out ways to reward registered reports as part of the funding process and incorporate them into open science and data management plans.
Great.
So
Thank you,
that's
Amanda.
it for me. Thanks.
All right. So reminder, put your questions in the Slido link. I will repaste that after the next person starts talking, which I can go back to my slides. That would be Matthew next. So Matthew, take it away.
Matt
7
Giampaolo
minutes,
here.
please.
I can't share until the screen is. Oh, okay, great.
There we go. All right, 7 minutes, please.
All right, hope you can see that. My name is Matt Giampaolo. I'm Vice President of Publications at the American Geophysical Union, AGU. I'm happy to be here and talk to you a little bit about what we're doing at AGU and also learn from what everyone else is doing to advance open science practices, particularly around publication validation. So I want to thank Mia Ricci, who works with me on the running the peer review internal in-house teams at AGU. Also, Shelley Stahl and Christina Braunvelder, who work in our open science leadership team at AGU. Some of these slides are theirs. In fact, Christina is the one standing next to the data help desk presentation there, and I almost took that picture out, but I'm also in this picture talking to the person in the suit at the right hand side. So that was at our last meeting. AGU has a meeting of over 7,000 people in December we had. So a little bit about AGU. We have our publications include 24 peer-reviewed journals. We've been moving steadily to increase our open access. So we have 12 fully open access journals, 12 hybrid journals, which are subscription journals with open access options. It takes a lot of people to make our journals run. I have 27 staff. We have over 800 editors and associate editors because we have more than 17,000 submissions a year and publish more than 8,000 articles a year. We also have a books program, which we're trying to push to more open access options, and all of this is overseen by AGU's Publications Committee. I think you all know about open science, but what I want to say here is that we've got really big issues that humanity is dealing with, including things like climate change, dealing with natural hazards and limited resources. Open science can help us come together convergently, tackle the problems humanity is facing. And open science isn't just open access. You all know it includes things like fair data, reproducibility, and inclusive practices. And I'll be talking to you about some things we've been doing on data. All of this, I always like to say we have to balance our goals. We want to do more open science at data, but it has to be balanced with sustainability of operations and inclusivity. We don't want to be bumping people out of participation for the extra work we're asking them to do. So we always keep that in mind as we're rolling out new projects. AGU has for 20 years now more seen our Earth and space science data as a world heritage. We have a specific policy statement about it. It gets updated every now and then, and it has really been guiding our actions over the past several decades. We recently, about 5 years ago, when I joined AGU, we were just at the beginning of this, rolled out data and software guidance for authors where we require authors to share the data and software needed to understand their work. And that means that they need to do three things. They need to give us they need to put their data in a repository that gives it a DOI that permanently shares that data. They need to do an availability statement describing the data, where it is, how it can be accessed, and they should cite the data. To start with, we rolled this out slowly, journal by journal, and it took staff and editors getting to a place where they would start actually pushing back papers when they didn't do this. So it was encouraged before, and this now was a requirement that people have to meet. And we started with really the first two, and then have now graduated to making sure people are properly citing data. One sort of glitch in our data journey that Shelley Stahl mentioned has really pushed forward is getting the data citations connected to being tracked and through Crossref, so that if somebody cited your data, that you get credit for that, or that gets measured and can be picked up later. So Shelley has done a lot of work with various groups, including Crossref, typesetters, publishers, to make sure that we actually, if somebody cites the data with the DOI and the citation section, that will get picked up and connect on through. Parallel to that, as we were doing our pilot in this past year, just over a year, we started now adding in enforcing the data citations and tracking how many data citations, what's the percentage of data articles that have data citations. So as you can see, at the end of, early in 2022, we added GeoHealth as our first journal. We started pushing back the articles if they didn't have a citation, and then began to add clusters of journals after. And we've steadily started to see that we're up around 90% of our papers have fully functional data citations in them. Again, fulfilling all three of those things: deposit your data, make a data availability statement, and actually cite the data. This is an example of one of the things we have to check for to really make sure people.
So 1 minute, 1 minute warning.
This is my last slide anyway. Really getting people to say what the citation is, that it is a data set or it is software, and these bracketed statements. It was one of the keys to getting this picked up and through the Crossref system. We're doing lots of other things. I'm happy to talk about them if anybody has questions during them. I'll stop sharing.
All right. Thanks, Matt. Great. Okay. Our third talk is from Gus. Take it away. 7 minutes, please. We cannot hear you, but we see your screen.
Can you hear me now?
Yes.
Great. Is my screen clear enough, or should I go to full screen?
Full screen would be great, but that might also break it.
Yeah, we'll see. Did it work?
It's good. Go for it.
Thank you. So, hi, my name is Gus Minch. I'm a data editor with the DOIs journals. And I wanted to talk about our approach to sort of the stage right before validation. So I don't think that my slides will get to validation as a concept, but to the work that we're trying to do to build pieces for validation. So what do I mean by a data editor? We work with the authors to standardize and document the data, and in the sense, I'll give some details on the different phases that we work with authors. There were three of us. The first one was hired in 2000. I was hired in 2014, and we just hired a third last year. And we really, work with authors in two different phases. We review about 90% of the 5,000 submissions per year in what we call like data review. And I'll show in a second what that involves. But basically, the broad goal is to examine the quality of the linking and citation and sharing of the data and software that are in an article. And we only started that in 2016 after 16 years of focusing on curating the material and author in journal articles sort of after they've been accepted. So this secondary post-acceptance editing phase, each of us does around 600 articles per person per year. And then we edit the data. We're trying to standardize the material that authors are providing so it can be ingested into other repositories. And then a really blossoming thing that we've been working on is either curating the data or the metadata for data that are in open repositories. We're not the only people in the world that are doing data editing. I give three examples there, and I have some references at the end that I think might be useful for Rebecca's goal of, what are the other kinds of validation efforts that are out there. I think there's some really interesting examples from economics. So this is data review. I just wanted to give a list of the things that we look for when we're doing this initial review. We have some tools in our submission system that let us pluck out terms from articles, so we know which ones to look for. We look for links to data. We make requests, like why is that in Dropbox? Why is that not in a repository? And then we bundle these recommendations up into a review that comes in parallel to the science peer review. And this was interesting in a talk earlier. Tim Vines said, about DataSeer that authors really like hearing earlier in the process about the things they need to do, and also being told what the requirements are for openness and the requirements are for sharing. So here's my curve of growth graph. So there are a bunch of lines on here. I'm only going to talk about a couple. The green heavy dashed and the heavy blue lines represent like tables or actual data that are in the journals and their growth over time. And so you can see in 2014, we started producing a lot more tables. These are standardized tables that can be reused. The other lines relate to interactive figures in the journal. I'm not going to talk about that. The line I want to draw your attention to is the heavy brown line, and that heavy brown line represents an uptick in DOIs to data sets. That's a combination of citations to data that are already in our repositories, and also to data sets that are being deposited into places like Zenodo. Rapid exponential growth in the journals, and so we have to sort of change how we're working with these materials to ensure that they're well curated. So these are the three questions that Rebecca asked us to reflect on, and I'm going to focus on two of them, one positively and one more antagonistically. So we're having to work with these repositories heavily. And so when we talk about tools for relationships between repositories, authors, and journals, I want to highlight the one that we've been working with since October, and that is the repository Zenodo. Years ago, we wrote that we really wished repositories would make for open curation models, and that's essentially what's happening here. This is our dashboard for the AAS journals. Since October, we've worked on 100 submissions to Zenodo. And what I work on is that sometimes the authors will deposit that material before they ever submit the article. So they have the flexibility to do that. But then they submit it to the journals or community on Zenodo, and we can do a variety of things when it's been submitted for review. We can make requests. We can check that the metadata in that repository is high quality. Is our files well described? Is it well licensed? Are the author lists complete or meaningful? They also can submit it for draft review. So we could even go in and we could edit the material. We can augment the files that are supplied by the author with better files that are standardized according to, a headerless CSV file is replaced with a CSV file that has proper column metadata. So we can do these edits, and then once it's in the community and published, we can do additional kinds of linking. So in a PRC model, the curation that comes later, we can add links. We can improve the relationships in these records on Zenodo. And the authors know this. 1 minute. Okay, I'm done almost. So the authors know that we have this ability when they submit. Okay, so that was on the topic of how to make this system work a little bit better. This is a challenge. This concept of validation is a huge challenge. And this is my antagonistic proposal that people who are building the platforms, and I'm sure Brian and Rebecca are tweaking right now because I know about their projects to do this a little bit more better than what I'm describing here, but that we don't not building platforms to preserve bitwise data, and we're certainly not providing platforms for reuse of software. And that produces a challenge if you want like push button reproducible results. If you want some kind of validation, and if you don't believe me, here's some links, and especially read the second to last link, the 2023 report from the AEA on the economics data editors and the problems that they have, even when you have a system that's designed for validation, maintaining that validation over time. So I'll stop there.
That's on time.
Right. Thank you, Gus. Alberto, you're next. Are you ready?
Yes, I am.
All right. The floor is yours. Go for it. 7 minutes.
Okay, thank you, Rebecca and Brian. All right, so I'm going to talk about the NASA Science Explorer and how it promotes fairness through metadata enrichment. So first of all, what is the NASA Science Explorer? So the easiest way to describe this is to say that it's an extension of the astrophysics data system to all of the disciplines that the NASA Science Mission Directorate covers. I gave a brief presentation in another session about this. So this is just for those of you who haven't seen the website before, I encourage you to go to sciexplorer.org. But if you've used the ADS, so the Astrophysics Data System, it's very much a similar experience. It is a literature-based portal that astronomers use almost daily, and increasingly more people in space sciences and in the future Earth sciences will be using. So how does what we do for feeding data to the Science Explorer relate to data discoverability and reproducibility? So first of all, some disclaimers in a way. We're primarily a literature database. So even though there are a couple of ways in which data products and software can become records in our system, we are very much interested in tracking these products as they relate to published scientific articles versus becoming an all-out data repository where you can expect to find all data products related to, say, astrophysics research. That's not what ADS or SciEx are. So our goal is to sort of capture the relationship between articles and the associated data products so that they can be accessed and reused by scientists who are accessing and reading the articles. So the types of data products which are typically of interest to us are what I call data sets close to the publication. So this is the data behind the figure that Gus was talking about, links to archival data sets that were studied in the papers, and through citation links, whenever a data set is formally cited, then that link can be captured by our data ingestion pipeline. So the type of citations you can find are citations to existing data sets whenever those data sets have been published with a DOI, or when the author themselves creates supplementary material and deposits that in, say, a database such as Zenodo. And also software records fall into this broad category. There are two ways in which we populate and enrich our metadata. One is through text and data mining. Essentially, what this happens by mining the full text of the papers. We receive manuscripts from all kinds of publishers, but they include the American Astronomical Society and the American Geophysical Union journals. And then we look in those papers both for formal citations, which we process on a regular basis, but also we look for data availability statements when they exist. And whatever links appear in a data availability statement, then we say, okay, these must be data links. And we capture them and we make them available through our interface. Now, even though we obviously prefer DOI links, at this moment, we're capturing all links in the hope that they would be useful for reproducibility purposes. The other way in which we aggregate and link data to existing records is collaborating with a number of curators that work at different archives and data centers. So this is how traditionally data had been linked to the literature in astronomy. There are people whose job it is to track how their data has been used in the literature at astrophysics archives hosted at HESARC and Chandra and the Space Telescope and IPAC and JPL. So these are curated collections of links, and these links typically get shared and incorporated in our records so that we have bidirectional links. ADS will link to the data products hosted by the different archives, and the archives link back to us. For software, we have exactly pretty much the same situation. So once again, there is a more consolidated approach. There is a single project called the Astrophysics Source Code Library, which maintains curated links to the literature, and which creates a registry of software products. But also at the same time, we have in place a pipeline that finds software citations in the literature. And when that citation is found as a formal citation, we incorporate that into our database. So we do create records for software, and they get linked with the corresponding papers. And let's see, this allows us to do interesting things. So you can, because we index part of this information, one can use our search engine to find interesting things related to data and literature linkages. So as an example, I put some examples here. The second example, for instance, finds all records that are either software or a data set in our system. The third example shows how an astronomer can...
1 minute warning.
Yeah.
Sorry.
This third example shows how an astronomer can find papers that have data sets related to 2 X-ray missions, Chandra and XMM, as well as an optical archive. So this finds multi-wavelength papers because they have data from different archives with different characteristics. The fourth one shows all citations to article of all software records. And the last one is an example of a more complicated thing that finds citations to data sets or links to data sets. So here was my summary and some of the challenges which we discover when we actually do all this text mining is that the quality of the metadata that we get by ingesting and creating records is all over the map. And also, frankly, the sort of the meat grinder that the articles go through before they reach Crossref and other data consumers makes it so that a lot of the linkages are not as clean or they're not as well annotated as we wish. So if we talk about reproducibility, we should also talk about what needs to be done to make these workflows more reliable and better. And I'll stop here.
Thanks, Alberto. That's great. Right on time, too. All right, so thanks to all of our presenters for keeping us on time reasonably well. We have 9 minutes left in our session. So I'm going to hand this over to Brian to guide us through the questions on Slido. There are already some answers in the chat that I'm going to work on copying over to notes.
Yeah. Do you want me to ask questions that have already been answered in the chat, or do you want to just flow with the top questions that have been upvoted? So as a reminder, you can go in and upvote. I'm just going to take the top one now, but it doesn't mean you can't upvote something that you want asked. As long as we have time, we'll keep asking the panel. Are we ready?
Go for it.
Yep. Okay. So a question about data citation for anybody. Do you mean the data that's used by the research or the data that's produced by the research, or both? And is there any difference in how these are cited or should be cited?
Who is that question for?
Yeah, I think all of us have interesting answers.
Well, whoever wishes to go first. Maybe the panelists raise their hands and then we'll go in that order real quick. Try to keep it brief though. All right, so I see Matt. Matt, you go. You fastest on the
Yeah,
draw.
so it's definitely, from our perspective, it's both, and authors should use their data availability statement as a place to explain which data they generated and which are used by others. Obviously, when you cite someone else's data set, you should also be citing any papers they've written about it. But citing something, and even if it's already in your data availability statement, in the in-text citations and in the reference section, it just makes everything connect and flow up to all the other things we heard about today about how we can track what people are citing and reusing.
All right, thank you. Alberto?
Yeah, same answer. I just wanted to point out one additional thing, which is there are ways to associate relationship between to these citations. So you could say this data set is a supplement to this paper, and that expresses the meaning of that link, citation link, versus reuse of data from some other research or archive.
Okay, great. Gus.
And I just want to add to that there exists so we're very focused on like trying to differentiate between data citation. So my career growth is a mixture of all kinds of new ways of citing data that haven't existed 5 years ago and are now coming into existence, and also, you know, the records that authors create. But I want to point out also that the relationships that are created, you know, perhaps we create a relationship to a data set, those relationships actually come back. So Alberto talked about, you know, that they work with archives that establish, oh, this data set was used in that article, and then it's captured at ADS and expressed at ADS. But those inbound relationships actually also require some kind of curation. I mean, in a networked world, we want to be able to see that these data sets are being, oh, this data set was used. Well, maybe we as a journal need to be thinking about, you know, those inbound relationships, and how do we then express them as augmentations of the articles that we have, right? So these things, there's all kinds of asynchronicity here that needs to be thought about.
Yeah, I think we could probably just talk all hour on just this one thing, but we've got to move on. The next voted question is about the 50 gigabyte limit. It's been answered by Gus in the chat. So are there other panelists who want to take up here's the question. How do the journals handle data sets that are larger than 50 gigabytes, free limit on Zenodo and similar? You don't have to answer it. And then I'll offer the opportunity to Gus if you want to modify or add anything additional quickly about this in your answer.
Well, I would just say that sometimes we, you know, our editors are certainly having a conversation with people about what subset of the data they can share and should share. You know, as it was mentioned, there are simulations. You don't need all of that. Just representative examples of some of the simulations could be appropriate. And find the best repository for your data.
Yeah. So speaking as the lead on heliophysics data repositories at NASA, we also struggle with this and try to figuring out. I think there need to be some best practices or rules put in place for triggering when it is that we would store such large data sets. It's challenging. Okay, so we'll move on to the next question that was upvoted, that it's on my list here. Is the goal to simplify review or to make it more accurate? Are these in tension? That's a bit of an open question. Okay, maybe it would help if someone in the audience can provide some further description of what's being asked.
I'm wondering if maybe this was about registered reports. I was trying to keep track of the time of when this was asked. But I'll say for registered reports, I think the goal is to decouple the assessment of the methods from the results, which is to say it's very, very hard cognitively for humans to see both of those things at the same time and to not ding the methods if the results come out unexpectedly or vice versa. So the two-stage evaluation in a registered report is really to set up a situation where reviewers can assess the methods in absence of the results and evaluate, is this the right way to go about answering this question? And decouple that from either the surprisingness or unsurprisingness of the actual results themselves.
Thank you, Amanda. Matt, you have your hand up.
Yeah, however the question was asked, there is definitely a lot of tension between giving the readers and reviewers more information and the amount of time that those people want to invest in actually doing the review. So we definitely get reviewers pushing back on our questions to them saying, can you look at the data? That some of them get really angry. And they certainly get angry if we haven't done our job to make sure all the links are working and everything. So there's definitely tension.
Okay, thank you. We'll move on from there. Do repositories enforce version control on datasets? Can you update a dataset without breaking old citations?
I can try to answer that.
Yep.
I can, yeah. I mean, I think that I don't. The the generalist repositories, the big ones, Dataverse, Zenodo, those have different kinds of version models that would not break citation, right? In some cases, the DOI doesn't change. There's an internal version model that changes. With Zenodo, all the versions are linked together. I think there's some interesting social constructs here to talk about where someone has a data set and then as a function of peer review, it's revised, and then they have a final data set. And that's kind of an interesting thing. They think about their preprint. A preprint is a pre-version, and then you have a published version. And that's okay that they're different because this was before and after. But I'm not quite sure where they are on data. So while we do have versions, are people accepting that the one version the initial version is different than the final because of peer review or other kinds of changes?
Interesting answer. I can't help myself but to follow up by asking, is there some best practice here that we as a community could come up with in terms of what should be followed in terms of the versions that are allowed in publication or how we do this? I mean, is there any consistency now? It doesn't sound like it.
I don't. Let me think back.
Well, you can ignore my question. It's maybe a bit much. We'll move on from here.
I think like
Well,
NICE and others will increasingly, apply standards to these things. And there are some that I'm just not expert enough to point to.
Well, we
Okay.
are out of time. If I think we have to call it. I do find this conversation interesting enough to maybe shoot the wall about it and propose a session at AGU to have some deeper conversations across our sciences. So if you see that, then be happy to continue this conversation there, or maybe sooner than that. But I wanted to say thanks to all of our presenters and being mindful of the time. Let's go ahead and call it here. Thank you all.